Hello everyone. So today we are going to revise another chapter of the chemistry, and that is chemical reactions and equations. Fine students, I hope you are now clear with the chemical reactions and chemical equations. So what are chemical reactions? Anything that it change its original state or original position is known as chemical reactions. Fine. The thing is, any element or a thing or a substance whose change is its own original identity, who changes its own original identity is known as chemical reactions and equations. Is known as its chemical reactions and equations. Fine. See, there are various types of examples given over here, and that is milk left at a room temperature during summers. Milk left at room temperatures during summers. An iron tawa pan nail left exposed to the humid atmosphere, it can change its color or it can also be rusted. Grapes gets fermented, as we have talked about the fermentation process. Okay, the alcohol, that was the glucose being produced by the fermentation of the grapes. When the yeast attacks on it, food is cooked, food gets digested in our body by the help of an hydrochloric acid and the respirations. All are reactions. Generally, the reactions or say the chemical reactions are divided into two main portions: the physical reactions and the chemical reactions, also known as physical changes and chemical changes. So, the physical changes are the change in states or a change in color are known as physical change, whereas the change in the molecules, the change in the boiling points, the change in the melting points, etc. are considered to be a chemical reaction. Okay. But how can we determine either the chemical reaction has taken place or not? That we need to see. See, they have also given one of the activity over here, and they are talking about burning a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Let us see that. The activity needs the teacher's assistance. It would clean a magnesium ribbon about 3 to 4 cm long by rubbing it with the sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or a burner and collect the ash so formed in a watch glass. Okay. So we can see over here, you must have observed that magnesium ribbon burns with a dazzling white flame and changes into white powder. Okay, this powder is magnesium oxide. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. It is formed due to reaction between magnesium and oxygen present in the air. From the above three activities, we can say that either the reaction has taken place or not. See students, if in examinations they are asking about that determine whether the chemical reaction has taken place or not, then there are 4 steps to determine whether the chemical reaction has taken place or not: change in state, change in color, evolution of a gas, change in temperature, etc. Fine students. So what is that? Change in state, change in color, evolution of a gas, change in temperature. As we have observed the changes around us, we can see that there is a large variety of chemical reactions taking place. Fine. We will study about the various types of chemical reactions and their symbolic representations. First of all, let us start with the chemical equations. What is chemical equations? How do they happen? So, the simplest way to write the chemical reactions or the chemical equation is to write its spellings or write its name in the form of word or an equation. But if the chemical reaction or a chemical equation is elaborated, that means it is long, it is difficult to write everything in the form of words in the case of molecules and number of atoms if we have to represent. Okay. So, the substances that undergo chemical change are known as reactants. The substances that undergoes chemical change, the elements which are going to be changed. I hope you can understand students. The substance which are going to change its original identity or they are going to lose their identity are known as reactant, and the chemical reactions which are changed already, that means from the reactants they will give another new compound, and that is known as products. That is known as products. Okay students, so it is written over that is a magnesium plus oxygen will give you magnesium oxide. It will give you magnesium oxide. Fine, I hope you are clear with this students. If you are having any doubt, then you please let me know. So this is also known as skeletal chemical equation for the burning of magnesium air. Okay, Mg plus O2 gives MgO. See, we are having a periodic table in which we have written each and every elements over there. Each and every elements are denoted by some or other words or letters, and thus if we are writing a chemical equations, we are only going to use the same common letters or words using this chemical reactions. Okay. The next thing is balanced chemical equations. Students, I hope you are now already clear with the balanced chemical equations. Still, once the school gets started, we are going to learn this in deep. Okay, but I cannot teach you just now in the form of examples. I need to have a board. So we were moving on to the next topic, and that is different forms of chemical reactions. Okay, simple forms of chemical reactions. Let us see that. And that is the types of chemical reactions. See students, as we all know, there are various types of chemical reactions: combination reaction, displacement reaction, decomposition reaction, double displacement reaction, oxidation, reduction, and the combination of oxidation and reduction is said to be redox reaction, as well as the exothermic reactions and the endothermic reactions. Fine, I hope you are clear with this. Let us check that. We have learned in class 9 that during a chemical reaction, atoms of one element do not change in those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and the making of bonds between atoms of products, new substances. You will study about two types of bonds formation in these chapters. So let us start with a combination reaction. Let us start with a combination reaction. See students, the word itself explains what is combination reaction. Okay, calcium oxide reacts vigorously with water to produce slaked lime. See, if we are having two elements or two molecules and they combine to form one single product, I repeat, if we are having two molecules or two reactants and if they combine to form one single product, that is known as combination reaction. That is known as combination reaction. A reaction in which single product is formed from two or more reactants is known as combination reaction. Okay, a reaction in which a single product is formed from two or more reactants is known as combination reaction. I hope you are clear with this. See, it is given over here, that is the calcium oxide, also known as quicklime, when gets reacted with water, that is H2O, gives CaOH twice, that is slaked lime plus heat. Slaked lime plus heat. Okay. See students, you also need to know that the calcium oxide, that was the quicklime, is also used for whitewashing clothes or whitewashing walls. Okay, a solution of slaked lime produced by the reaction is also used for whitewashing walls. Calcium hydroxide reacts slowly with carbon dioxide in air to form a thin layer of calcium carbonate on the wall. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the wall. Okay, I hope you are clear with this. See, if you don't know, then you can write the common examples in the examinations also. Say for example, it is given over here that C plus O2, so that is CO2. C plus O2, that is CO2, that is carbon plus dioxygen will give you carbon dioxide. Or it is also given about the formation of water, that is 2H2 plus O2 gives 2H2O. 2H2 plus O2 gives 2H2O. Fine students. So if two single products combine to get one combined answer, it is known as combination reaction. It is known as combination reaction. Okay, fine. See, if the heat was produced in the reaction of the calcium oxide, then you need to know that the reactions in which heat is released along the formation of products are also known as exothermic chemical reactions. Okay, reactions in which heat is released along with the formation of products are also called exothermic chemical reactions. Fine, reactions in which heat is released along with the formation of products are also called exothermic chemical reactions. So in any reactions or in chemical equation, if heat is produced together, it is known as exothermic reaction. It is known as exothermic reactions. Fine. They have given us certain examples of the exothermic chemical reactions. You can see over here, that is CH4 plus 2O2 will give you CO2 plus 2H2O. Okay, fine. I hope you are getting this, students. See, we all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simple substances. For example, rice, potatoes and bread contains carbohydrates. These carbohydrates are then broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. Okay, so it is given over here that if you are having a glucose molecule, that is C6H12O6 plus 6O2, that was the reaction of the respiration that we have also learnt in chapter number 6, life processes. Okay students, C6H12O6 plus 6O2 will give you 6 molecules of carbon dioxide plus 6 molecules of water and energy. See, you can also see over here that the energy is produced, that means the heat is produced, that is exothermic forms of reaction, that is exothermic forms of reaction. The decomposition of the vegetable matter into compost is also an example of exothermic reaction. The decomposition of vegetable matter into compost is also an example of exothermic chemical reaction. Okay, where heat is given out along with the formation of a single product. I hope students now you are clear with the combination reactions. Let us move on to the next topic, that is decomposition reactions. Okay, so what is decomposition reaction? In decomposition reaction is actually the anti-combination reaction, or it is the inverse of combination reaction. It is the inverse of combination reaction. Fine students, let us see that. See, they have given us the example over here, that is about the green ferrous sulfate crystals. If we are having a ferrous sulfate whose general formula is 2FeSO4, whose general formula is 2FeSO4, in the presence of heat, Fe2O3 plus SO2 plus SO3, that is 2FeSO4 in the presence of heat will give you ferric oxide plus sulfur dioxide plus sulfur trioxide. Okay, so what happens from a single reactant, so it breaks down to give many simple products. If we are having a single reactant and it gets broken down into many smaller products, it is known as combination reaction. It is known as combination reaction. Fine, sorry, my mistake, sorry. It is decomposition reaction. Okay, see, they have also given various examples over here. Let us read that. Ferrous sulfate crystals, that is FeSO4 7H2O, loses water when heated and thus its colors also changes. It then decomposes to ferric oxide, that is Fe2O3, sulfur dioxide, that is SO2, and sulfur trioxide, that is SO3. Remember that ferric oxide is a solid while SO2 and SO3 are gaseous compounds. Okay. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Okay, decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is also called quicklime. Calcium oxide is also known as quicklime. Students, you need to know for the examinations too that the general formula for calcium oxide, the general name for the calcium oxide is quicklime. It is quicklime. CaO. That is Ca is calcium, O is oxygen. Fine, students. It has many uses in the manufacturing of the cements also. When a decomposition reaction is carried out by heating, it is also known as thermal decomposition reaction. Please note that, students. When a decomposition reaction is carried out by heating, it is also known as thermal decomposition reactions. It is given over here that CaCO3, that was the limestone, when heated gives calcium oxide plus carbon dioxide, gives calcium oxide plus carbon dioxide. Okay, students. You will observe that the emission of brown fumes, these fumes are of nitrogen dioxide. Please note that the brown colored fumes are prepared from nitrogen dioxide. Okay, nitrogen dioxide. Fine, students, see the activity. Take about 2 grams of lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. What happens? See, the reaction is given as 2PbNO3 twice. It is one of the most important reactions, as I have told you earlier. You please need to know it by heart. Okay. Fine. So 2PbNO3 twice, that is lead nitrate in the presence of heat, gives lead oxide, that is 2PbO plus 4NO2 plus O2. Okay, 2PbNO3 twice gives 2PbO, that is lead oxide plus nitrogen dioxide plus oxygen. Okay, fine. See one more example. It is also known as the electrolysis of water. It is also known as electrolysis of water. This type of reactions, such as the electrolysis of reactions and all, are also used for gold plating and silver plating on simple metals. Fine, where gold and silver are being coated on the simple metals like a copper, brass or bronze, so that they look like a real gold. Fine. Take a plastic mug, drill 2 holes at its base and fit rubber stoppers in its holes so that the water cannot insert. Connect these electrodes to a 6 voltage battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to water. Take 2 test tubes filled with water and invert them over 2 carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. What happens? This bubble displaces the water in the test tubes, means they will produce water in the test tubes. Okay. It is the volume of the gas collected the same in both the test tubes? No, they are not. Test these gases one by one by bringing a burning candle close to the mouth of these test tubes. Okay. What happens in each case? Which gas is present in each test tube? See, they have also given us the various types of reactions present in electricity, respiration, that is the exchange of gases, sunlight, etc. Let us see that. You will see that white silver chloride turns grey in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. That is 2AgCl gives 2Ag plus Cl2. 2AgCl gives 2Ag plus Cl2. That is silver chloride turns grey in sunlight to form silver metal. So there is also a type of decomposition reaction, students, that is 2Ag in the presence of sunlight will give you 2Ag plus Cl2. The same thing is happening in the silver bromide. That is 2AgBr in the presence of sunlight will give you 2Ag plus Br2. These above reactions are also used in black and white photography. Okay, please note that the silver bromide and the silver chloride are also used in the black and white photography. We have seen that the decomposition reactions require energy either in the form of heat, light or electricity for breaking down the reactants. Please note that students, the decomposition reactions require energy in the form of heat, light or electricity for breaking down the reactions, and the reactions in which heat is absorbed or energy is absorbed. I repeat, the reactions in which heat is absorbed or energy is absorbed is known as endothermic energy, is known as endothermic chemical reactions. Fine students, I hope you are clear for this. Fine. I hope you are clear with the combination reactions and decomposition reactions. Let us move on to the next topic, and that is the displacement reaction. That is the displacement reactions. Okay. So what is displacement reactions? Take 3 iron nails and clean them by rubbing with a sandpaper. You know the sandpaper will make it rough. Okay. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml of copper sulfate solution. Take 10 ml of copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in a test tube B for about 20 minutes. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color. You can see that the iron nails or the copper sulfate solution have loose color, as well as the iron nail has also changed the color. That is, from an iron nail it becomes corroded, that was containing some sort of copper sulfate solution. It is containing now copper sulfate solution. Okay, as well as the copper sulfate solution, which was blue in color, has now changed to colorless solution. Okay, fine. Next, why does the nail become brownish in color and the blue color of the copper solution fades? Okay, so the same thing is over here. It is displacement, that is the exchange of molecules from one form to another. Where the element is strong, it will change or replaces the weak element and takes its own place. Say for example over here, we are having Fe plus CuSO4, and Fe is made up of, nail is made up of Fe, that is iron. When reacted with CuSO4, that is copper sulfate solution, gives FeSO4. So what happens? Iron is more reactive than copper, then iron has took place of copper, and so now the reaction becomes Fe plus CuSO4 gives FeSO4 plus Cu. So you need to know that whenever in a chemical reaction one element displaces or removes another element, it is and takes its own place, is known as displacement reaction. It is known as displacement reaction. Please students, I am repeating one more time. In any chemical reaction, when one more reactive element displaces the other weaker element or takes its place, it is known as displacement reaction. Fine. See students, there are various types of examples also given over here. That is Zn plus CuSO4. Zn plus CuSO4 will give you ZnO4 plus Cu. Then zinc is replacing the copper. The same thing is over there down. Lead plus CuCl2 will give you PbCl2 plus Cu. I hope students you are clear with this. I am repeating the definition one more time. Please note that whenever in a chemical reaction the more reactive element takes place the weaker place or removes the weaker element, it is known as displacement reaction. See, from all the examples given over here, you can also check that the copper is said to be the least reactive chemical reaction. Least reactive chemical reaction. Zinc and lead are more reactive elements than copper. They displaces copper from all its forms. Okay, let us move on to the next topic, and that is double displacement reaction. That is double displacement reaction. So students, let us see what is double displacement reactions. From the name itself, you need to know that what is double displacement. If in displacement in a chemical reaction, one element or one compound was getting interchanged, here two chemical reaction gets interchanged, or we can say the two atoms or the two molecules of the following reaction gets interchanged, and that is known as double displacement reaction. That is known as double displacement reaction. You will observe that a white substance which is insoluble in water is formed. See students, you also know that the insoluble substance formed is also known as precipitate. The insoluble substance, the element which is not soluble in water is known as insoluble substance, and that is known as precipitate. It is also known as precipitate. Any reaction that produces a precipitate is also known as precipitation reaction. Reaction that produces a precipitate is also known as precipitation reaction. Fine. So what they are telling us, let us read the activity and then we will solve the chemical reaction. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride. Mix the two solutions. What do you observe? Let us see that. So in the first beaker it was Na2SO4, that was sodium sulfate. Okay students, Na2SO4, that is sodium sulfate, that is aqueous, plus barium chloride, that is BaCl2. Okay, will give you BaSO4, that is barium sulfate. So Na2SO4 plus BaCl2, you can see over here that sodium will take the place of barium and barium will take the place of sodium. So what happens? Na2SO4 plus BaCl2 will give you BaSO4 plus 2NaCl. BaSO4 plus 2NaCl. Fine. So you can see over here that the sodium and chloride will get mixed up and it will form a salt, that is 2NaCl. And BaSO4, instead of sodium sulfate, now we will be having barium sulfate. So this is known as double displacement reaction. Fine. Such a reactions in which there is an exchange of ions between the reactants are also known as double displacement reaction. See students, above the activity 1.2, it is the definition is given. You need to write that in the exam. Okay. Reactions in which there is an exchange of ions between the reactants are also called double displacement reactions. Fine students, I hope you are clear. From tomorrow we will be starting the oxidation and reduction. Thank you.